Hi gang, for test 1 we're going to go over 2i. So when you plug in 5, you get 2 minus 5 over 5 minus 5, so we get negative 3 over 0. And remember, whenever you get a number over 0, we're looking at a vertical asymptote. And it's important to note that you're coming in from just the left side. So if you're hitting a vertical asymptote, and you're coming in just from one side, remember there's only two things that can happen. Either when it hits the vertical asymptote, it's going to go up to positive infinity, or it's going to hit the vertical asymptote and go down to negative infinity. So it's got to be one of those options. If you get a non-zero over 0, it's positive or negative infinity. So we know the answer is positive or negative infinity. We just have to figure out which case. So how you figure that out is you pick something a little less, right? You're coming in from the left. So you pick something a little less than 5. Now make sure you make it just a little less, okay? So something like 4.9. So if I plug 4.9 in for x, in the numerator, 2 minus 4.9 is negative. 2 minus 4.9 is negative. In the denominator, 4.9 minus 5 is negative. So I have a negative over a negative, which is going to make a positive. So therefore, this is going to equal to positive infinity. Okay, that's the answer on this one. So try to remember, if you get a number, a non-zero over 0, you're looking at a VA, you're looking at an unbounded scenario. Okay, now because you're going to infinity, you have to make sure you follow the correct rules. When you go to infinity on a rational function, that depends on the degree. So I'll briefly say what the rules are, but this is from section, my brain is saying 4.6. This is the chapter 4 section on limits. So if you recall the rules, if the degree of the numerator is higher, it's going to positive or negative infinity. If the degree of the denominator is higher, it's going to 0. If it's equal in degree, it's the ratio of the leading coefficients. Okay, so whenever x is going to infinity on a fraction, or what we would call a rational function, you have to look at the degrees. So since the degree of the numerator is 2 and the degree of the denominator is 4, this means that it's going to equal to 0. I tried to make up some funny words in the lecture. I called it top heavy, bottom heavy, equal in degree, things that try to help you remember the rules. So if you notice in the lecture, I said this would be like bottom heavy, meaning that there's a higher degree in the denominator. So that means that since there's a higher degree in the denominator, this number will get huge relative to this number, right? This number is going to get bigger faster. So if you think about things where they're both growing, this happens to be going to negative infinity, but I just give a positive version. You want to think about that both sides are growing, but they're not growing at the same rate. They're not growing at the same rate. Okay, and after a while, you know, if you have $4 split by 10,000 people, they're all getting close to 0. So if there's more in the denominator, as you go to infinity, this will collapse to 0 because the denominator will become a huge number divided by a much, and the numerator will stay relatively small. Okay, gang, that's it. Again, this is like, my brain's saying 4.6. It could be 4.5 if I'm a little off, if you want to review those rules for fractions. Okay, gang, I'll catch you in another video. Bye-bye.